Hello everyone, welcome back to the channel. In today's episode of SQL Sunday, I will be talking about Aleo, which in case you missed part 1, Aleo is a privacy blockchain, and yeah, it's a new blockchain, and so I'm trying to learn and share my findings as I explore the data on Aleo. Now, part 1 of Aleo, I talked about the blocks, so block rewards, puzzle rewards, all that fun stuff. But in this episode, I recently managed to decode a DEX on Aleo, which I believe is the most popular DEX, called Arcane Finance, and I'm here to just share the sequel of how I managed to decode the DEX data on Arcane. Alright, so before we begin, there are a few things you need to know about Aleo transactions. I think it is very similar to either IBC or EVM, such that it has a transactions table, right? And each transaction has one row, and it sort of like describes or encapsulates all of the things that go on within the transaction. Okay. So if you think about like Ethereum fact transactions, right, it's just the same as Aleo. And then in Ethereum we have event logs or traces. In Aleo there's transitions instead. So the way I understand transition is like, I think the best way is just to describe it as an event. So sort of like an event logs of Aleo, right? But the thing that I noticed about transitions is that a lot of data overlap, and also some data is hidden. There is some encryption behind some data, and so we cannot really use all of the data in all of the transitions. And because I'm looking at a particular event, like the DEX swaps in Arcane Finance, I have to use transitions. So I'll be using transitions, and yeah, I'll just show you what it looks like. Now you can query transaction by yourself. Oops, how do I? Oh, there you go. Right, it has your usual block ID, block timestamp, transaction ID. Index would be the order of the transition within a transaction, right? There can be many transitions within a transaction. And then transition ID would be the ID of the transition, right? And then I think the other few things that will be important is program ID, which is, you can think of it as a contract address in the event logs table. And then function is similar to event name or topics 0 in event logs. And then inputs and output, together they make up the data, alright, in event logs. But input is what you supply, and then output is what is I guess the output. But it's not always, you can't always get the stuff from output. So meaning we almost always have to rely on inputs. I think that's all the important bits to know. Now, I think an important thing to know about DEXs is to know how DEXs work in general, right? So I'm going to use Ethereum for example, right? So DEXs on Ethereum, there is a pool, factory address, right, that creates all the pool addresses, and then users interact with either a router or the pool address directly, right, for swaps, right? And in a swap transaction, several events can occur. Similarly, several transitions can occur, right? But the events that occur are, for example, one is you transfer some assets to the pool or the router, right? And then maybe the pool, does his swap and then transfers the swapped asset back to you, right? And then lastly, the pool emits a swap event, right? So this is a typical structure of how you would see dexes. If you look at event logs for dexes, right, there's some sort of transfer, and then the pool emits an event. Now, why I'm showing you this is because all this is very relevant to how the dexes work on Aleo as well, right? There is some sort of address that creates all the pools, and then when users interact with Arcane Finance, right, this is the Arcane Finance UI, when they swap between assets like Aleo and USDC, there is a transfer, right? You transfer the assets to the pool sends it back to you, and then it emits a swap event. So to decode Arcane Finance, we essentially have to first find out the creation of all the pool addresses, right? Which is from where this pool factory is from. And then secondly, get all the different types of swaps based on all these pool addresses. Okay? It will be a different video than usual because I'll not be doing the manual queries because they're quite long. I'll just be walking you through what I've done, right? So the first thing I've done is okay, so I guess the first thing that we need to do is to get the pool address, like where are the pools created from, right? There has to be a factory address, and turns out there is, and it's this program ID called Arcane Pool v2.2.2. And if you, the way I found this is, I just looked at a bunch of arcane transactions like this, right? This is a swap on Arcane Finance. And again, the way to get this is to either you actually do a swap or you simulate the transaction, and all the inputs will show up and you can get some information there as well. And I found this particular pool where it says Arcane Pool v2.2. Okay, I click into this pool, and over here it tells me all of the different transitions or event names that the pool can do. And there is one particular transition that seems interesting to me, and it is the create pool transition. Okay, create pool transition, and that's why I use this to query, right? Filter the program ID, filter the function create pool, and then get essentially just get the raw value, which is what is the output of the creation, right? In this case, it is in outputs, not inputs. And the output of this is a bunch of like gibberish things. So you can see here. Can I try to copy this? See, it's not exactly a JSON because these are not enclosed in double quotation marks, right? And so I just dumped this into ChatGPT, told it to help me help me to clean up the JSON file essentially, and it came up with all these regex. So yeah, I just copied it and used it, and the final result of this is of course something beautiful like this, where I can then query each key value pair. Okay, so that's the, I guess, important information. First important information. The second important information is that on the pool address itself, like this is the pool address, you can click on read mappings, and these are sort of like reading a token on Etherscan. Like maybe I'll just look it up and show you. So you know how on Etherscan you can sort of go to contract and read contract, and it gives you the name, total supply. That's exactly what this mappings is. So in this case, you can give it the pool address, or the pool address, and then you click read, and it'll tell you the ID of the pool, which is this. What is the token 1, token 2, right? All these are important information, right? So essentially what we're doing here in our query is we want to get the pool address. Yeah, so we did all this cleaning just to get the pool address, and we then use this pool address, plug it into the API, which is here, right? And it tells us, oh, sorry, not this, this one, and it tells us token 1 and token 2. Right, when a pool is created, especially like a Uni v2 pool, there is a token 1 and token 2, and so this represents that. And so you can find the API from their docs as usual. Yeah, I was just able to live query it very easily, right? Get the pool address, and then again do a bit of cleanup, and I end up with things like this, right? Where I can see what is the pool address, what is the token 1 and token 2. Okay. Now, what's missing from me is that even though I know the token 1 and token 2, I don't know what is the name of token 1 or token 2, right? And I don't know the symbol and also decimals to divide it by. And so that's where another contract or another function, contract called token registry comes in. And token registry seems to be like a Aleo's native program where you can create new tokens. And so if you were to put a token ID here in this registered tokens mapping, it tells you the metadata. Right? It tells you the name, the symbol, the decimal, supply, so on and so forth. So then again, you can imagine we will use live query to get all this information, right? And then join it back to our pool table, so that our final pool table would have what is the pool address, what is token 1, token 2, what is the name, symbol, and decimal for token 1, and again the name, symbol, and decimal for token 2. So that's the point of us using this live query to get the mapping of this. Now, another thing, if you notice, is that the name is weird, right? It's like this number and U128. Now, I've done a lot of testing, and I found that this needs to be converted to a string. So first, copy this and convert it into hex. So for example, copy this, convert to hex. You get the hex data. Copy the hex data and convert from hex to string. And that tells you the name. I mean, it converts whatever that we see here, this name, into the actual name, which is Pondo Aleo LSD. Okay, so again, we need to go through this two-step thing to decode, which is first converting it to a hex, and then from hex convert it to a string. Okay, yeah, so this is the pool address basically, and then like I mentioned earlier, this is where I get all the distinct tokens from the pool address. Use live query to get the metadata of the tokens, and you will see that in the raw results of the clean JSON, you can see, token ID is what, name is what, right? All this is available now. Now I have a final table where I combine everything to tell you what I've told you earlier, which is a final table that shows you what is the pool address, what is the swap fee, what is token 1, token 2, what is the name, right, symbol. All this I decoded, where you can see I decoded from into hex, and then again from hex to string. And the final result of this is this wonderful table where I have it's like an equivalent of the DeemDex liquidity pools table that we have. Cool, so that's part 1, which is getting the pool from the factory addresses. And part 2 is swaps. Now, I would say swaps is the easier bit, because once you find out the pattern, yeah, it's pretty easy to know and to locate what you need, right? So let's see. So again, you can get examples of swaps by actually doing the swap, or proceeding but not actually committing to a actual swap. And similar, like MetaMask, the Leo wallet sort of pops up and tells you all the inputs, which you can then use to make to see, find patterns and sort of decide which transition to use. And from what I've seen so far, this is the most consistent transition, where again we use this pool program and using the swap AMM function. And so there may be other functions in the future, right? But in this case, I just filtered for the swap AMM function. And lots of different stuff here, but once you sort of see the pattern, you can sort of make sense of what all this means. Like, for example, this is the pool address, and then if you see a cipher here, this means this is encrypted. There's no way to decode this unless you have I don't know, the private key or something. And then this is a number, and this number refers to the token in amount. And then this is a token address, and this would be the token out address, and this is token out amount. And then I don't know what these two are, but yeah, essentially those 1, 2, 3, 4 is all you need, and it's all that I've queried from this function itself, right? Pool address, amount in, amount out, token out. And because I know the pool address, what is token 1 and token 2, right, from our final index liquidity table, I can then join that with my swaps table. And so after joining the swaps, I can do this coalesce thing to get me what is the token out and token in, right? And I think that's it, right? Just by doing that, it already tells you, it already gives you, amount in, amount out, token in, token out, pool address, right? But there's one more thing that's missing, and that is the swapper, like who actually did the swap. I didn't include it here, but yeah, you get the point. Yeah, and for that I rely on again this same thing, but instead of relying on this one like we did, I relied on this. So I noticed that there are a bunch of different programs out there. There's like v2.4, right, 2.3, and I just used this, verified that the number of rows matches, and I figure out that this address is the address that's swapped. And so it's a simple CTE to get the swapper and then join the swapper on transaction ID. Of course, I qualify to make sure that we're only pulling in one swapper per transaction. Now, this also assumes that there are only one swap event per transaction. I did verify that, but it's not impossible that there may be multiple swap events in the same transaction in the future, and that's something I have not seen or considered, but it might happen. Either way, this I think gives you at this point of time all of the swaps. Yeah. So again, to summarize, because we know the structure of dexes on EVMs, we can follow this structure to look out for what would be relevant for us, right? We need the pool address, and then we need the actual swaps. And to get pool addresses, I looked at this create pool event, cleaned it up a bunch, and then found that I can get the metadata from this program. Use live query to get the metadata excuse me, and then I got the pool metadata. I need the token metadata, and so I use again this token registry program, get the token metadata, join it back to my pool, and yeah, that produced the final dimensions pool table, right? I have all the necessary information I need here to then join with my swaps. That gives me the final swaps table. Yeah, so I think in general the way to decode Aleo would be what I've highlighted throughout when I went through all this, right? There's always going to be some information that's not available but still available within the same transaction, just appears in a different transition, and so you have to find a way to join the two, and then just have to make use of this mappings thing to get some data that is not easily decodable. And then for fields that you can decode, for example, name, decimal, right? You have to convert the integer to hex, and then from hex to text. I think that's it from this video. I hope you learned a lot about working with Aleo data. It took me a while to get this, but I'm hoping that this would help and sets you on a better, I guess, framework of how to decode your Aleo transactions. Alright, that's it from me. If you've not watched part 1 on Aleo blocks, do watch the video. And yeah, thanks for watching. See you all next time. Bye.